Hello, Algebra 2H. This week we are going back to chapter 10, and we are going to do 10.5 this week, 10.6 next week. The reason why I switched that up is, like I said, chapter 11 had some good connections to the unit circle, and I thought it was more challenging than what this is going to be. So I figured for the next few weeks we'd have some things that were a little more straightforward to understand, and hopefully you guys will agree with that. So 10.5 is about the law of sines, which is something that you've already done in geometry. We're also going to learn how to find the area of a triangle using these formulas. So you can find the area of a triangle by doing 1/2 times the sides lengths B and C multiplied by the sine of A. When you are labeling A, B, and C, the side lengths that are across are notated with the lowercase letters. So these are other areas of a triangle, but we're also going to talk about where those come from. So usually when you are finding the area of a triangle, you're thinking of area equals base times height. You don't have to write this part down. I'm just showing you how this came to be. So if we're looking at a triangle, ABC, so we'll label this lowercase a, lowercase b, lowercase c. If we wanted to find the area, we would do 1/2 times the base, which is right here, times the height, which is the dashed line that I have drawn. But in the triangle, if you are given an angle measure, so let's say we know that this angle measure is 73 degrees, you are able to find it using the sine. And let's talk about why. So if we were trying to find what the height is here, we could use our SOHCAHTOA. So this would be the opposite side. The height would be the opposite side. C would be the hypotenuse. So if we were to do the sine of 73 degrees, we know that that would be O over H. In this case, the opposite side is the height, and then the hypotenuse is C. So one way that we could find what the height is to multiply both sides by C. So then the height would equal C times the sine of 73 degrees. Now, if you plug that in using substitution into the formula for H, you would have the area equals 1/2 times B, and then instead of H, you'd have C times the sine of 73 degrees. And that's how we get our formula. It's 1/2 BC, and then the sine of 73 is angle A. Okay, so that's where these area formulas came to be. You don't necessarily need to know that part, but one good thing to keep in mind is the way that these came to be is that we know that the sine of A was equal to the height over side C, which means the height, H, equals C times the sine of A. And that is something we're going to come back to, is that height there. All right, so for example 1, it says to find the area of the triangle, round answers to the nearest tenth. If it helps you, you can go ahead and label your sides as A, B, and C, and it doesn't really matter the order that you label the vertices as long as the sides across are labeled correctly. So to find the area of this triangle, you can use the area equals 1/2. You have A and B, so this would be AB times the sine of C, which is what we have here, and then we're going to plug them in. If you look at the position, it really just is as simple as noticing you have an angle side angle, or side angle side. So this is a side angle side. situation, sine of 40 degrees. Okay, and that you can calculate with your calculator. Obviously, we know that 3 times 5 is 15, so I'm just going to do 15 times a half times the sine of 40. Make sure that your mode is in degrees because you are substituting in a degree. So it has to be in degrees. So if you notice that you are getting some of these answers wrong, that's the first thing I'd ask you to check, is that you're in the right mode. It says round to the nearest tenth, so this would be 4.8, and then your units would be meters squared. Okay, and then for B, we're gonna label that ourselves. So your triangle, this is gonna be A, B, C. And you are given this side is 13.6 feet. So side AB is 13.6 feet. BC is 10.1 feet. And you are given side AC is 17.4 feet. And angle B is 76 degrees. Okay, now in the first one, they just gave you everything that you needed. Now they're giving you more than you need. So remember I said you want to look for that side angle side type of situation. So if this is your angle B that's in the middle, you could also just say, oh, I know that B has to be my angle, so I'm going to use the area is 1/2 AC sine of B. So this is going to be 1/2. Little a is across from A, so 10.1. Little c is across here. And then this is going to be the sine of 76 degrees. All right, and then we're going to calculate that. So I'm going to do 10.1 times 13.6 times 1/2 times the sine of 76 degrees. Okay, and then we're rounding to the nearest tenth, so this is going to be 66.6 feet squared for my area. Okay, and then again, like I said, you're looking here for the side angle side, and maybe that is something you remember from geometry too. There's actually a lot of geometry in these next couple sections. So the law of sines states that the sine of angle A divided by A, that ratio is the same as the sine of B over B and the sine of C over C. Remember, we use 2 of the ratios, set them equal to each other, and cross multiply to solve. You can also prove this using all of these equations. I'll show you it just real quick. If you set all of those equations equal to each other, then you can derive the law of sines. So if you multiplied each side by 2, okay, then you'd be left with this, and then you could divide each expression by ABC, and you'd have some cancellations that would result in your law of sines. Okay, so with your law of sines, you can solve a triangle as long as you know either of the following. So you'll either know 2 angle measures in any side length, which would give you an angle side or angle side angle situation, or the second situation is where you would know 2 side lengths and the measure of an angle that is not between them. Okay, so this situation would be 2 side lengths and the measure of an angle that is not between them. It can't be any angle. So this is what we call the ambiguous case. This would be the SSA, which We put the S's first, if you know what I'm saying here. When you were in geometry, we talked about how this was not a triangle congruence because it spelled a naughty word backwards. And this is called the ambiguous case, which we'll do more with the ambiguous case in a moment there. Okay, so then we have to solve each triangle round to the nearest tenth. Like I said, these are both problems that you have done before in your geometry class. So the main thing you want to look at is first you want to find what I call a matching pair. So a side length and an angle across from it. When the directions say to solve each triangle, what that means is you have to find all the angles and the side lengths. Okay, so find all angles and side lengths. Well, the first thing I would do, if you're given two angles first off, you know that in a triangle it's 180 degrees. So to find the measure of E, you would just do 180 minus 28 minus 33 to get 119. Okay, so that's the first thing that you would do. I'm just going to label it here. Okay, so that's the measure of angle E. Okay, now I have all the angles. Now I'm going to work on the side length. So when you find a side length, you want to find the matching pair. The matching pair is you have the side length of 15 and then the angle across from it. So to find the side length, you can set up the sine of 28, and remember, whatever the sine is of, it has to be an angle measure. So the sine of 28 over 15 equals, and you can choose what you want to solve for first. So if you want to solve for D, I would use the sine of 33 degrees over D, and then I would cross multiply to solve for that. With E, I'm just going to put a little thing here. Again, you want to use the given measurement because you know that's not rounded at all. Some of the other measurements might be rounded. And then this would be the sine of 119 degrees over lowercase e. So to cross multiply, what happens is you multiply 15 times the sine of 33 degrees. That would equal D times the sine of 28 degrees. But then to get D by itself, you divide both sides by the sine of 28 degrees. I'm not going to write this out every time. Like I said, this is something that you've done before. So you will do 15 times the sine of 33 divided by the sine of 28. And it says to round to the nearest tenth. So you'll get 17.4 for D. And really, as you begin to do this a lot, you'll see, oh, for E, I'm multiplying 15 times the sine of 119, and then I am dividing by the sine of 28. So 15 times the sine of 119 divided by the sine of 28. Make sure that you do close that parenthesis. You'll get a different answer if you do not. And then you will get 27.9. And this doesn't have any units on it, so you don't have to worry about putting your units there. And then one way you can check yourself too is remember from geometry, the largest side is across from the largest angle. So at 119, the largest side should be across from it. 27.9, that is the largest of our three sides. Across from 28 should be the smallest one, 15. And then the 33 is 17.4. Okay, and then for B, this one is really the exact same as the one that we just did. Generally, if we were in class, I would just have you, do that to see if you could repeat the steps that we just did. So if you want to try that as an extra practice one, you can, using the triangle sum We know that angle P would be 105 degrees when you subtract from 180. And then when you solve for Q, you would get 6.1. And then when you solve for R, you would get 6.5. Okay, so I don't want to kill you with the videos. Like I said, it is the same steps that we have up here. So if you want to do that one and see if you can get those answers and write your work there, that would be an excellent thing to do. And then I'm going to make a new video for the next page because you guys seem to like that better. Okay, thanks.